Hello Internet! Today we have a tutorial on implementing gaze with the Hololens to switch materials on objects in Unity. As we see here with these vehicles, by default they're wireframes, but once we gaze upon them, they turn into solid metal and rotate. And I'm able to kneel down and look at this vehicle from every angle as it's spinning around the middle of my living room. Likewise, I can also manifest metal onto the surface of this plane. And it's a pretty straightforward effect that hopefully opens the door to many possibilities using gaze. Now these materials just jump. However, we'll also go over smoothly transitioning materials, such as on these buttons. So this will be a fun effect to learn, and hopefully it will open the door to many possibilities. Here in Unity, I already created the basic scene we'll be working with today. The main things we need to add to work with gaze are Holotoolkit's input manager and maybe a cursor. You'll see that I've already imported the Holotoolkit, which is indispensable for Hololens development, and some standard assets like these planes and cars. Also created some basic materials to play with. So let's go into the Holotoolkit, input, prefabs, and insert an input manager in our scene. Now it's good to hold managers, services, and providers in a dedicated empty object like this managers class. We'll also add a cursor. You can drag this basic cursor out under the camera, and if I give the scene a quick run, we'll see that the cursor works. You'll see that it does collide against objects, and it collides against the plane, and it collides against the car, and right now there's no behavior, so we'll need to write a few scripts. And it's logical to assume if we're going to transition between materials, we'll probably transition between many things over the course of a project. So let's create some basic reusable functionality. So let's just create all the scripts we'll need. I'll need transition behavior base. Let's assume that we can reuse the same logic for all our transition components. We'll also have a gaze transition base. So that will automatically invoke the callbacks for when we receive and lose gaze focus. And let's start with the blocks. So the blocks will smoothly transition when we go in and out. So let's also create a script for gaze material transition. And let's start editing these in Visual Studio. Opening the file in Visual Studio, we see Unity's default scaffold. The first thing you should always do is add a namespace so that other people know where your script is coming from and what its purpose is. Also, since this is a base class, it won't hurt to make it abstract, because that will enforce the fact that it doesn't actually perform behavior on its own. It's a facilitation for other behaviors that extend it. That said, we don't need these start or update callbacks. But instead, we'll define what will be shared. One of those ideas should be a properties object for different transition properties. So what's nice about Unity is if we define a public serializable class, it will actually show up as an option in the GUI within the editor. So let's have a class called transition options with a public float transition in duration default to 1, a transition out duration also default to 1, and we'll mark this as a system t.serializable so that Unity can render it in the GUI. What's more is we can put tooltips on any public property in the GUI. So let's add a tooltip for the time in seconds to transition from 0 to 1. Likewise, we will go from 1 to 0 on the transition out duration. So these are a little self-explanatory, but for some properties it's very useful to have a tooltip, so it's a good habit to get into. Likewise, everything with a transition behavior should have these transition options as a public property. Next, they should all share the concept of a transition factor or some other analog value to represent how far along we are in the transition. We can make that protected. Next, let's set up some public methods to invoke a transition. So we'll know we'll need to transition in, and we'll also need to transition out. And if we're transitioning in or out, it stands to reason to have a common transitioning logic. So let's create a coroutine to actually perform the transition. In Unity, a coroutine represents a way to perform non-blocking operations, and it works great for interpolating values over time. They will always return an IEnumerator of the type of how long to wait before continuing processing. It can process right away, it can return after a number of seconds. So let's call this coroutine transition 2. So we have transition in, transition out, transition to. So we're going to have a few parameters: float from, float to, and float duration. So even without getting into the logic, we can already see how we can reuse this in our public methods. First thing we'll do is invoke the inherited stop all coroutines method, because we might already be transitioning and we don't want to have any strange artifacts. The next thing we'll do is start coroutine passing our coroutine transition to. And if we're transitioning in, then we're going from 0 to 1. And we'd like to take the transition options, transition in duration. I'll just copy and paste this into the transition out, and instead of going from 0 to 1, we'll go from 1 to 0. And I'll take the transition out duration. Now the only thing that's left is to actually implement this logic to perform a transition. So knowing the duration, it will be helpful to translate that into a rate. So the rate will just be the reciprocal of that duration. So we'll divide 1 by the duration. Next, we'll use linear interpolation to perform the transition. So let's set up the scaffold of this coroutine. We know we'll want a loop. So let's use t to represent how far along the curve we are. So while t is less than 1, we'll want to perform our interpolation function. So first, let's return back to the main process. Returning null means that we'll return instantly. So this may or may not be desirable. While we're done with this loop, we want to ensure that our transition factor is equal to what we wanted to transition to. Now, the issue here is t is starting at 0. If our transition factor is already some value between from and to, we should probably start there. If we're using linear interpolation, we can perform an inverse lerp. to get the appropriate t value to begin with. Next, we'll want to perform a linear interpolation. So our transition factor will equal mathf.lerp from to t. Now all that's left is to increment t by some function of time. So the static class time exposes a few different useful properties for keeping track of time. Delta time is the time in seconds since the last frame. So the other enhancement we can make is this might actually process again before the frame is over. So we can actually return a new wait for end of frame. So this is a type of time measurement to tell Unity to wait on this coroutine until the end of the frame. Now the problem here is if we're constantly creating a new class instance, that will impact performance eventually. So we can just make this static. Let's create a static reference. So under public protected, let's have private static read only yield instruction, because that's the type of wait for end of frame. End of frame equals new wait for end of frame. So there's no reason to not share this instance because they'll essentially do the same thing. So we'll copy this and return it here. So every time this loops, it will yield until the beginning of the next frame. Next, we'll go into our gaze transition base, which will actually extend transition behavior base. And now you'll see the value of namespaces. So if they're in the same namespace, then I won't have to include anything extra. It's automatically associated. And this will also be an abstract class. And you might start to think this is getting a little over-engineered, but you'll see the value of this soon enough. The other thing gaze behaviors need to do is implement iFocusable from the Holotoolkit. So Visual Studio is telling me I'm missing an import. Then it will tell me I'm missing the implementations. So let's build out that scaffold. And since this is a base class, we won't need the start or update methods. Instead, we're going to focus on the interface implementation. And all we need to do is say transition in on focus enter and transition out on focus exit. Now we're ready to look at actually transitioning materials. Let's put our gaze material transition class in the same namespace as the others. And let's extend gaze transition base. The new properties we'll need are the public properties to define the materials we're transitioning to and from. So let's have public material, active material, and public material, inactive material. So some tooltips. Oops. Tooltip. Material displayed when gazed upon. Tooltip. Material displayed when not gazed upon. Pretty simple to understand. Now to switch materials, we'll need a reference to the current renderer. And we can use Unity's get component or get component in children, but doing that every frame would be taxing. So let's just set a property to store that. Now in our start method, let's bootstrap our renderer property. We'll use getComponentInChildren because it's a good idea to put your meshes and other renderables in a layer under a sort of higher level empty game object to hold all the behaviors of your current prefab. So if this were a light up block, the actual cube would be a level under a game empty. On update, we should see if we actually have a renderer. If not, we can return from update because there's no work to do. Otherwise, the renderer object has a reference to its primary material, and this will make it so easy because there is a lerp method to automatically transition between two materials given a value. So we know we want to go from our inactive material to our active material, and we'll use the inherited transition factor. So you see, all that boilerplate for transitioning makes it really easy to make behaviors that will transition different properties or elements. And we can clean up some of these unused imports. Let's see what this looks like in Unity. So let's test our script so far in Unity. Let's put the gaze material transition on our light up block. So now when we inspect it, we see the public properties, and you can see how a serializable class turns into a collapsible menu in the GUI editor. So let's set our materials. I have a lit and unlit version of the block material. Lit and unlit. Now we'll hit run. And there's our plane, and there's our block. And we can see that in about a second's time, it fades in and out. Let's duplicate this block. But first, let's create a prefab. So I'll drag this light up block into my prefabs folder, and I'll duplicate it. I have my snap settings to 1/4 meter, so I'm just going to hold Control and move it. Duplicate again, and now I have a nice little set of 3. Let's duplicate those. And duplicate those. Now let's see what happens. I kind of would like an effect where I see a trail of these. I would like it to fade out slower than it fades in. Luckily, we set up a prefab, so if we alter the prefab, every instance will reflect that. So let's transition maybe a ½ second to transition in, and maybe 4 seconds, or maybe 3 seconds to transition out. That's pretty. And that's essentially it for transitioning materials, but the problem is I'd like a more complex shift for these two vehicles here. If we look at the materials lit and unlit block, they both use the same shader. And to use material.lerp, you have to have materials that share the same shader. Ideally, the only thing that changes are things like textures and float values. However, if I want to go from this wireframe material to one of these blue shinies or gold shinies, and please excuse the crude cube map that I created, but it works really well with these complex shapes. So what I'll do is create a new script that will toggle the material. So this is probably the initial script you would use when trying to transition between materials. So let's call it a gaze material toggle. So not to be ambiguous with transition, this will be an instant shift. Editing the behavior, we'll start of course with a namespace. And everything so far is an effect, so that's nice. So we need to implement iFocusable. Now these meshes are very complex. They actually have multiple renderers within them, so we'll need to save an array of renderers this time. And I like to have the lifecycle functions up top, so that's why I just moved the implementations downwards. So let's have a private renderer array. And in our start menu, we'll bootstrap that. Oops. Get components in children, so that will get a full array of all the renderers associated with this game object. Next, we'll have the same materials that we'll use in Gaze material transition. So I'll just copy and paste those. Let's create a helper method. We don't need an update method because this is going to, it's not going to smoothly transition. So let's create public void set material, because we're going to use the same logic. So for each renderer in renderers, we're going to set material to material. So when we start, let's set it to the inactive material. Likewise, we'll set the inactive material on focus exit and set the active material on focus enter. And that's essentially it for this. Let me get rid of some of these unused imports. So now, going into Unity, let's select the aircraft and choose the toggle. Gaze material toggle. Also see how Unity translates your names into much more readable text. So the active material will be a blue shiny, and the inactive will be a wireframe. For the car, we'll do the same thing. We'll use the toggle and a wireframe inactive, but it will be a gold shiny for our active material. And that works basically as we expect. So as we look at the vehicle with the cursor, it will change material. And it will affect every object within. So for example, if we look at the car, we can see it has a number of unique meshes. Same deal with the aircraft. It has a number of unique meshes. So this script will go through each of them. Now, in the initial video, we saw a little bit of a spin. So just to see how else we can use this transition gaze boilerplate, let's set up a little gaze spin script. So we'll call this gaze spin transition. Similar namespace. And let's extend the gaze transition base so we have access to our gaze transitions. All we need to do really is have a max speed. So let's say we have a public float maximum spin speed. Let's say it's 30 degrees per second. So all we'll do is on our update transform.rotate, and you see it has a few different overloads. One of them is an axis and an angle. So all we have to do is rotate around the vector 3 dot up, so this will spin something around the y-axis, and we'll take our maximum spin speed times our transition factor times delta time. And that's it for this class. So you see this boilerplate really pays off easily to transition all sorts of properties. So let's place this on the vehicles. So we'll place a gaze spin transition on the aircraft and the car. And you'll see it speeds up and slows down. If we change the transition options, we can make it take some time. Let's let it really speed up and see what happens. So if we make it take maybe 3 seconds to get up to speed, just to see that smooth transition. Versus the car, which has the default value. And that essentially concludes this tutorial. So I'm hoping that this gives people ideas on how you can use gaze and how you can think about setting up boilerplates for logic that you might reuse, because that's how you make code more maintainable. It might not get you the immediate result you want as quickly, but it does make your code easier to expand and maintain. So thank you for watching and have fun